Welcome. We've been often hearing from those pushing the idea of a grand solar minimum that the sunspots we've been seeing recently are too weak and are indicating that we're heading for the grand solar minimum, or the grand solar minimum has just started, in fact. However, of course, the sun, as usual, loves to prove forecasters wrong, and it's done so again. It's produced a nice large sunspot region in the southern hemisphere at the moment. We're going to take a look at its development over the last few days. So when you look at a sunspot group, what is there to see? Let's go over the anatomy of a sunspot. The dark area in the center of the sunspot is called the umbra. It is where the strongest magnetic fields are. The strong magnetic fields inhibit the flow of energy from below, so the area becomes cooler and therefore darker. Surrounding some of these spots, there's a gray area called the penumbra. This is where these strong magnetic fields are starting to radiate out and connect back to the surface of the sun, the photosphere. And then between these spots and around them, there are often little satellite sunspots, and they have a role in all of this too. Many regions will have a strong leading spot, and some regions, and this one is one of them, has a strong trailing spot. These sunspots will have opposite magnetic polarity, and you'll see large X-ray loops joining the two of them. When you're looking for the flaring ability of a region, you must look at the size of the region. The larger the region, the more likely it is it will produce a large flare. The magnetic field strength, so the stronger the field, of course, there's be more energy in the field, so it can produce larger flares. But most importantly, the complexity. The more jumbled up the magnetic field is with positive and negative, the more likely it is to flare. Another thing to look for, which is a bit more subtle, is the dynamics of the sunspots. These large spots can sometimes rotate, and when they do, they wind up the solar magnetic field, putting more energy into it, and can produce very large flares that way. The other thing is sunspot translation. Some of these satellite spots will move around, and when they do, they can disrupt or make unstable the larger, stronger fields and create a flare. So we should be looking for all of these things when we assess a region for its flare ability. Well, what is in the movie? We're going to show two repeats of a white light channel from the Solar Dynamics HMI instrument from the 22nd to the 25th of August. So we've got 4 full days of sunspot development. And the place to look here is in the southeast, the bottom left part of the image. So let's repeat that one more time. So what can we conclude from all of this? Well, we've had a few C flares during this time, but most of them have been from 2859. That's the region up in the north, not the one that's been developing rapidly. Active region 2860 is yet to flare, but it's likely that it will if it continues to grow the way it has. And it also has the magnetic energy and complexity to produce larger flares. The sunspot number as a result of these regions on the sun at the moment is 42 and going up. So the sun is becoming more active again after a few weeks of dormancy. So over the next few days, let's expect at least some more C flares, but possibly something larger. So until next time, stay safe, stay well, and goodbye.